this cubic function, this polynomial, and see if we can look for the global maximum and minimum on two different intervals to see how adjusting your interval changes the rules on it. Okay, so no matter what, if you're looking for a global max or min, you're always going to check critical values and endpoints, always. And what you're checking is their y values. So let's say at critical values and endpoints, check y's, y values. Okay, what gets a little tricky is if you violate the extreme value theorem, you're also going to check discontinuities. So if needed, you're going to add discontinuities, open endpoints, or I never know how to say this, it's open-ended. We'll just say it that way, open-ended, meaning you don't have an endpoint at all, you just go all the way to infinity. So if you have to add any of these to your list, we're going to use limits. And it's not that we'll have to do a lot of limit work punching through algebraically, it's just that our thinking will be limit thinking. What happens as x goes to infinity? What happens as x gets really close to this discontinuity? Okay, so here we don't have any discontinuities, we don't have any open endpoints, it's not open-ended. So we're just going to check critical values and endpoints. So your first step is going to be to find the critical values. I've got the endpoints. So I'm definitely going to need to check f of -2, and I'm definitely going to need to check f of 13. So to find my critical values, I'm going to take f prime, which is 12x squared minus 90x minus 48. What can I divide out of that? For sure a 3. I take a 12 out of 90. 12 times 5 is 60. No, but I think I can get a 6. 6 times 15. Is that true? 60? Yeah, okay. So let's factor out a 6, and we get a 2x squared minus 15x minus 8, and then let's see if we can factor that more. So I'm going to have a 2x and an x, and then I get an 8 and a 1, and I'm trying to get 15, so let's do it. 2 times 8, there's 16, and 1 times x is 1, and if it's a -16 and a +1, I think we've got it. So our critical values are at -1/2 and at +8. Okay, so that means we'll also have to check -1/2 and +8. And this just becomes some calculator work. So because I'm lazy about having to type things over and over, one thing you can do is just enter your function. No cheating and looking at the graph until you're done. That's a fantastic way to check, but the whole point here is, can you figure this out without looking at the graph? And I'll be looking for all of this work very carefully. X plus 10. Okay, so okay, I'm going to go into the table feature. I don't like the way this one's set up, so I'm going to go into table set, and I'm going to set it to oh, ask auto. I actually do like it, I just don't like what's in there. So ask auto is what I want. Back into table, I'm just going to delete everything that's in here. I want to know what I get when I plug in -2, -1/2, 8, and 13. Okay, so I'm going to jot those down. -2 gave me a y value of -106. -1/2 gave me 22.25. And +8 gave me -1,206. And then 13 gave me 569. Okay, so again, remember, it's really important that you understand what we're looking for here. We are trying to find the very biggest, very smallest y value, which means we don't really care about slope. All we care about is making a really thorough list of everywhere that could happen, and then comparing the y values. So looking at my list, I've checked all the places I need to check, and it looks to me like I got a global max at x equals 13, and I got a global min at x equals 8. And I want to be really clear so I'm not mixing you up. There's a couple things I could ask. I could ask you what the minimum is, and I could ask you where it is. The what is is the y value. If I say what is the minimum, I mean what is the smallest y value. So the min of negative 1,206 happens at x equals 8, and the max of 569 happens at x equals 13. Okay, so there's the first one. I'm looking at my second one and it looks really boring, so I'm actually going to change it up a little bit. I'm going to go negative 2 to 1. Let's just get rid of that 0. So if I'm going from negative 2 to 1, I've already done a lot of the work, so I'll need to check f of negative 2, but I know that's 106, and I'll need to check f of 1, and then I also need to check critical values, which I've already done the work for. What you want to be careful about, so the critical values are negative 1/2 and 8, is that I don't care about the 8 because it's not in my interval. So negative 1/2 I do check, and I know I'll get a 22.5, 0.25, but I do not check 8. It's not on my interval. It can't be the global max. So I just need to check 1, which is negative 79. So now I got my minimum of negative 106 when x is negative 2, and my maximum of 22.5 when x is negative 1/2. Okay, so as I said, the graph is a fantastic check. I recommend it even if you're feeling confident about your answer, or you check the answer key, because I hope that it will help you see what we're really doing here. So let's see, we've already got our thing plugged in. So let's say we want to go from negative 2 to 13. So you can hit window and type that in, and then if you do a zoom fit, it should pick y values for you. So when we went from negative 2 to 13, you can see that our max happens at an endpoint and our min happens at the critical number, which is exactly what we got. Whereas when we change from negative 2 to 1, we now have our min happening over at this endpoint and our max at the critical number. And then let's see, let me just, I don't know, stretch this out a little bit more. Let's go negative 10 to 10, negative 10 to 20 maybe, since we had 13 already. Okay, so it's cubic, there's one critical number, there's the other. That's pretty good. So there's the function. So if we didn't have a closed interval, if we did all real numbers, we would get no max and no min. This goes to negative infinity on the left and positive infinity